Imagine for a moment you have a twin who lives on the opposite side of the globe. Regardless of the thousands of miles separating you, you both inexplicably feel the same emotions at the exact same time. If you stub your toe, your twin winces in pain. If you're ecstatic over a promotion, your twin, without any prior information, shares your joy. It sounds like something out of a science fiction novel, doesn't it? But this is the metaphor that best illustrates the mystifying world of quantum entanglement. In the quantum realm, particles can become entangled, meaning their states are inexplicably linked. Just like our hypothetical twins, these particles could be light years apart, yet a change in one particle's state instantaneously affects the state of the other. The question that has baffled scientists for decades is, how? How do these particles communicate with each other across vast distances? This question brings us to the heart of our quantum quandary. According to the laws of physics as we understand them, no information can travel faster than the speed of light. Yet, in the entangled world of quantum particles, it seems that they are playing by a different set of rules. Do they have some superluminal, faster-than-light communication channel we're unaware of? Or is there something fundamentally missing in our understanding of the universe? The concept of quantum entanglement challenges the very fabric of reality as we know it. It defies our everyday intuition and presents a profound mystery that scientists and philosophers have been grappling with since it was first proposed. So, as we delve deeper into this quantum quandary, remember our twins. They symbolize the entangled particles that, despite the enormous distances separating them, mysteriously know each other's state the moment it changes. This is the fascinating and somewhat eerie world of quantum entanglement. Just like twins with an inexplicable bond, entangled particles seem to know each other's state instantly. So, where does this spookiness begin? It all started with a physicist named Albert Einstein. Einstein, as you may know, was the man behind the theory of relativity, and he had quite a reputation for shaking up our understanding of the universe. But when it came to quantum mechanics, he found himself at odds with the theory's strange and counterintuitive predictions. Einstein was particularly bothered by what later came to be known as quantum entanglement. This is the phenomenon where two or more particles become entangled such that the state of one can instantly affect the state of the other, no matter how far apart they are. This didn't sit well with Einstein, who famously referred to it as spooky action at a distance. You see, Einstein was a firm believer in what's called local realism, the idea that an object's properties are determined by its immediate surroundings, and that information cannot travel faster than light. Quantum entanglement seemed to violate both of these principles, and Einstein was not having any of it. In 1935, Einstein, along with Boris Podolsky and Nathan Rosen, proposed a thought experiment known as the EPR paradox, aimed at demonstrating the absurdity of quantum entanglement. They argued that if quantum mechanics were correct, then the universe would have to be non-local, meaning that things could be instantaneously connected across vast distances. This was, in their view, an absurd conclusion that showed there must be something missing from quantum mechanics. But here's the thing. As much as Einstein disliked the idea of spooky action, subsequent experiments have shown that quantum entanglement is indeed real, and the universe truly is as spooky as quantum mechanics predicts. This doesn't mean that Einstein was wrong per se, it just means that the universe is a lot stranger than even he could have imagined. Einstein wasn't quite ready to accept that the universe could be so spooky, and who can blame him? After all, it's a pretty wild idea that things can be so deeply connected across the vast expanses of space. But that's quantum mechanics for you, always keeping us on our toes. Now imagine two dancers performing a perfectly synchronized ballet, no matter how far apart. Visualize this, two ballerinas, each poised on a separate stage. They can't see or hear each other, yet when the orchestra begins to play, they start to dance. Their movements are a mirror image of each other, each pirouette perfectly timed, each leap perfectly matched. It's as if there's an invisible thread connecting them, guiding their every move. This is a metaphor for quantum entanglement. In the world of quantum physics, two particles can become entangled, meaning their states are linked. When this happens, any change to one particle is instantly reflected in the other, no matter the distance between them. It's as if these particles are performing their own quantum ballet, their every move perfectly synchronized. But how does this happen? Well, that's the big question. Quantum entanglement defies our everyday understanding of how the world works. It's as if our two ballerinas can instantly sense each other's movements, even if they're on opposite sides of the world. Now you might be thinking, Wait a minute, doesn't that violate the speed of light? Well, that's where things get even more interesting. You see, this immediate effect doesn't involve any physical signal traveling between the particles. It's not like a telephone line or a wireless signal. Instead, it's as if the two particles are one and the same, twirling in unison across the cosmic dance floor. So picture our ballerinas again. No matter how far apart they are, no matter what separates them, their dance remains flawlessly synchronized. They leap, they spin, they twirl, and each move is perfectly mirrored by the other. That's quantum entanglement, a dance of particles that transcends space and time. In this quantum ballet, every step, every spin, every leap is mirrored flawlessly by the other, even if they are worlds apart. In today's world, this spooky phenomenon is becoming less of a mystery and more of a tool. Yes, you heard it right. Quantum entanglement, the seemingly supernatural dance of particles, is no longer just a quirky element of quantum mechanics. It's now being harnessed to build the technology of the future. Imagine a computer that can process information millions of times faster than anything we have today, or a communication system so secure that it's theoretically impossible to hack. These aren't just pipe dreams, they're real possibilities thanks to the power of quantum entanglement. Take quantum computing, for instance. Traditional computers use bits, ones, and zeros to process information, but a quantum computer uses quantum bits or qubits. These qubits can be both 1 and 0 at the same time, thanks to the principle of superposition. But here's where entanglement comes in. When qubits become entangled, a change in one will instantly affect the other, no matter the distance. This allows for an exponential growth in computational power. Then there's quantum cryptography, a method of encoding information that uses the principles of quantum mechanics to achieve unparalleled security. The key to this is, again, quantum entanglement. If anyone tries to intercept the information, the entangled particles would change state, alerting the intended recipients to the breach. But what does all this mean for our future? Well, imagine a world where computers can solve complex problems in the blink of an eye, where secure communication is the norm, not the exception. A world where quantum technology could help us make leaps and bounds in fields like medicine, climate science, and artificial intelligence. The implications are staggering. It's like we're standing on the brink of a new era, an era where the spooky becomes the standard, where quantum entanglement is just another part of our daily lives. Indeed, quantum entanglement, once Einstein's spooky action, is now at the forefront of technological innovation. A fascinating journey, isn't it? From the realm of the abstract and mysterious to the cusp of practical application, quantum entanglement is changing the game, and we're just getting started. So what does this mean for us and our understanding of the universe? Quantum entanglement, this seemingly eerie dance of particles, has profound implications not only for the world of physics, but for our very comprehension of reality itself. It challenges the very foundations of our understanding, calling into question the nature of space, time, and perhaps most importantly, connection. In the classical universe, we tend to think of things as isolated entities, separate and distinct. An apple is an apple, a star is a star, and never the twain shall meet unless they physically interact. But entanglement throws this concept out the window. It tells us that even across vast distances, particles can be intimately connected, influencing each other in ways that defy our everyday logic. This quantum connection, as it were, paints a picture of a universe that is deeply interconnected, where the fate of one particle can be tied to another, no matter how far apart they may be. It's a concept that not only challenges our scientific understanding, but has philosophical implications as well. It beckons us to rethink our notions of individuality and separateness, nudging us towards a worldview that sees the universe as a grand, interconnected dance. But let's take a moment to recap. We've journeyed from the quantum quandary through the story of spooky action and danced with quantum ballet. We've explored how quantum entanglement is being used today, and now we've tried to grapple with its philosophical implications. Quantum entanglement challenges the way we understand the universe, presenting a picture that is strange, counterintuitive, yet incredibly fascinating. It's a concept that continues to captivate scientists and philosophers alike, pushing the boundaries of what we thought was possible, and perhaps in a way, it's a comforting thought. In the vast, expansive universe, we are not isolated entities, but deeply connected, woven into the very fabric of reality. As we continue to explore the quantum realms, who knows what other surprises await us? In the grand dance of the universe, we're all a little entangled, aren't we?